Welcome back, guys. Now let us look at the fourth question of today's contest. The fourth question was find the median of the uniqueness array. What does the question say? We are given with an integer nums and the uniqueness of the array nums in the sorted array that contains the number of distinct elements of all the subarray of nums. In other words, it is a sorted array consisting of distinct for all this. Let me explain you with the help of an example. See, we were provided with the array nums. How is the uniqueness defined? The number of distinct elements in all the subarray of nums. So what all subarrays are possible? The first subarray is only 3. What are the number of distinct elements present in this subarray? 1. So we will have 1. The next subarray is 4. Number of distinct elements in 4 is 1. Again 1. Similarly, this also has only one distinct element. So one distinct element, again 1, and one distinct element, again 1. The next subarray is going to be 3, 4. The number of distinct elements in this subarray are 2. So we will add 2. In the similar way, we will find all the subarrays of this particular nums and we will find the distinct elements present in that particular subarray. And from that, we will make this uniqueness array. That is 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, and so on. This you can see it. This is the sorted array that contains the number of distinct elements of all these subarrays of nums. Now, what we need to do is we need to return the median of this particular uniqueness array. So we have got this uniqueness array now. Now the median can easily be calculated. And the number of elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Since the number of elements are odd, so the median is going to be the middle element, which comes out to be 2. So we are going to return. So what is the brute force approach that comes to our mind is we have the nums array. We will find all the subarrays. With the help of the subarrays, we will find the number of distinct elements and we will construct this uniqueness array. After constructing this uniqueness array, we can find the median very easily. We will apply this approach. So this is the brute force approach which is going to fail. Now, what can be the alternative approach? See, if we want to find the alternative approach, what we can do is, first of all, in nums, I can clearly see the number of distinct elements are going to be at least 1. If we are provided with an array, so the number of distinct elements are going to be at least 1. And the maximum number of distinct elements that are possible in this particular array is 3. That is 3, 4, 5. So it is 3. We can calculate it with the help of the map which I have used. So minimum number of distinct elements are 1. The maximum number of distinct elements are 3. What we are going to do is we are going to apply the binary search approach. What will happen in binary search approach is that we will, for every indexes, let us see the code only. What I am trying to do is, first of all, I have made one map. Then I have iterated through the entire nums. I have made this map to count the number of distinct elements in this particular vector nums. Now the size of this particular map will give me the number of distinct elements present in nums. So the minimum number of elements that are going to be distinct is 1. So int L is equals to 1. And the maximum number of distinct elements that are possible in this particular vector nums is the maximum number of distinct elements that are possible in this vector nums is m dot size. So I have initialized R with m dot size. You need minimum value, maximum value. In answer variable, I have declared one answer variable to store the to calculate the median of the uniqueness array. Initially, I have not defined it. Then I have made one variable nums to n to calculate the size of this vector nums, and I have stored it in n. The total subarrays that are possible for this nums is n into n plus 1 divided by 2. And the median min is total subarrays plus 1 divided by 2. What does it mean? It means there will be, if the total number of subarrays that are possible in this particular case is how much? In this particular case, the total number of subarrays possible are 5 into 6 divided by 2, which comes out to be 15. So 15 plus 1 divided by 2 will give me 16 divided by 2, which comes out to be 8. So this median min I have maintained. The use of this median min I'll tell you later. So now I have applied the binary search approach. What happens in binary searches? While L is less than equals to R, I have calculated my mid index. Now what this check function will do? I have maintained my check function. This will give me the number of subarrays that have the median value. Number of subarrays. this check function will do, it will return the number of subarrays whose value is lesser than or equal to mid, in which the number of subarrays in which the number of distinct elements are lesser than or equal to this mid index. So this check function will return me the number of subarrays. I will go to the check function and I'll explain you. If this check function crosses the limit of median width, this is the median width which we have defined earlier. If it crosses that particular limit, it means we can update. There are much possible answers. So we are going to update our answer to mid and R to mid minus. Else, we are going to update our L is equals to mid plus 1. If you have learned binary search, this approach would have been clear to you all. So for finding the number of subarrays in which the distinct elements are lesser than or equal to mid, which approach we are going to follow? We are going to follow the sliding window approach. What happens in sliding window is, we have maintained one map to calculate the number of distinct elements, one counter variable to store the number of subarrays whose distinct value is lesser than or equal to mid. And then L is equals to 0, R equals to 0. R will expand the window, L is equals to shrink the window. If the size becomes greater than mid, it means we have to shrink the window. And if it is not, then we are going to find the increment R minus L plus 1. This is the number of subarrays. So we are going to add it to our counter variable. So this counter variable will return at the end the number of subarrays in which the number of distinct elements are lesser than or equal to mid. When this loop will get terminated, whatever will get stored in our answer variable will be our answer. So the main condition is only this one, if condition. This if number of subarrays, this check function will return us the number of subarrays whose values in which the number of distinct elements are lesser than or equal to mid. Then we are going to update our answer to mid and R to mid minus 1. It means we are going to look to the right portion of the array. Otherwise, we are going to look towards the left portion. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.